In this video, we're going to talk about another of the conic sections called an ellipse. So an ellipse is basically an oval type shape. We've probably heard the word ellipse before, but we're going to look at this in a little bit more mathematical sense. Here's the formal definition of it. It's a little wordy, so just bear with me for a minute. An ellipse, by definition, is a set. It's a collection of all points, x, y, such that the sum of the distances between your point and two fixed points that will never move, called the foci. Foci is going to be an important word for us. Foci stays constant. Now, that, like I said, that's pretty wordy. So what exactly does that mean? Well, your 2 points called your foci will be two dots like this. Here I highlighted them in green. And let's say we picked a point like right here. So there's a distance from here to this focus, and the distance from here to this focus. Foci is the plural of focus. So two focus value points would be foci. So here we go. This distance plus this distance will give you a numerical value. Now let's say you wanted another point whose sums of distances stayed the same as this sum of these two distances. So if you went this way, in other words, if this distance got shorter, this one would have to get longer, right? You have to compensate. If it was like currently 7 and 3, if 7 went back to 6, 3 would need to go to 4, right? To keep that sum of 10. 7 plus 3 is 10, but also 6 plus 4, or maybe 5 plus 5, or 4 plus 6. You know, it's a little give and take that we have going on here. So if this is one point on the ellipse, then another point might be here, and another point might be here, and so on and so forth. And if you keep doing this, all these points sketch out this oval type shape. What you'll see a lot of instructors do if they want to do like a hands-on manipulative type thing, what you can do is take a sheet of paper and put two push pins in the paper, where you push pin down a piece of yarn or string that's just slightly loose. And if you pull it taut with like a pencil, basically the string on one side of the pencil, if you pull it tight, will be one distance, and from the pencil back to the other push pin will be another distance. And as you move the pencil around, you can imagine in your mind you would sketch out an oval like this. So imagine this is a push pin and this is a push pin, and this is string being held tight by our pencil right here. As you move the pencil back and forth, then you'll actually sketch out an oval type shape. So this is where you get an ellipse from. So that's all well and good, but now, like, how do you write that as an equation? Well, let's take a look at that next. So there's a lot of important vocabulary dealing with ellipses, probably more than any other conic section. So let's look at some of the words you'll probably hear. First word is the center. Every ellipse has a center. This one happens to be centered at the origin, but they certainly don't have to be. They can be up or down or to the side, or they could be centered anywhere. I just made this one at the origin just because it was easy. The next thing we need to know vocabulary-wise are the foci. The foci are the two fixed points that I talked about earlier. All right, the foci will be on the longer axis of the two. Either your ellipse will be elongated horizontally or vertically, and the foci will be on the longer side. And I'll talk more about that in just a minute. Now, beyond the foci, on the outer edges of the longest edge of the ellipse, you have what are called the vertices. You have a vertex on each side. Same as the vertex for a parabola, only you have two vertices because it's an ellipse. It's enclosed. So this is a vertex and this is a vertex. And remember, they are on the longer of the two sides. Now, you also have these things called co-vertices. You have vertices on the short edges, but they shouldn't also be called vertices, so they're called co-vertices. They're related to the vertices, but they're on the shorter side, not the longer side. And the next thing we have to look at vocabulary-wise are these things called the axes. You have a major axis, which is a chord between the vertices. So because they're between the vertices, they're naturally on the longer side because the vertices are on the longer side. and the minor axis is a chord between the covertices. So major, think longer, minor, think shorter. All right, and so these are all very important vocabulary words associated with ellipses. All right, now a couple quick notes. All right, first of all, I mentioned this earlier, the foci, remember those are along the major axis. And remember that the major axis is longer than the minor axis. Keep those two things in mind. All right, so now here's the big question. How do you write these as equations, right? So we understand what they are, but like how would you actually write one down with a pencil and paper? Well, it kind of depends if your major axis is horizontal or vertical. So is your oval shape flat or tall? If your major axis is horizontal, then your formula is x minus h squared over a squared plus y minus k squared over b squared equals 1. And if your major axis is vertical, then it's y minus k squared over a squared plus x minus h squared over b squared equals 1, where the a is greater than the b. So since the a is the bigger number, if the major axis is horizontal, the x goes with the a, which makes sense if it's horizontal and your major axis is horizontal. And the y goes with the larger number if the major axis is vertical. So at this moment in time, you're going to just have to memorize these formulas, but I promise you when we do some examples, I'll give you a lot more intuitive ways of remembering this formula here. First, one thing I'll say right now is notice how close this resembles the equation of a circle. X minus h squared plus y minus k squared equals r squared. Ours is a little different because it's an ellipse and it's elongated, but having the x squared plus the y squared makes you think ellipse as opposed to another conic section like a parabola or hyperbola or something like that. Okay, a couple notes here. What are these A's and B's? We see these A's and B's and the H's and the K's and that sort of thing. The major axis here, the longer axis, this distance here from the center out to the vertex, this is going to be A. So you have A on both sides from the center out to the vertex. So the major axis is 2A units long. And the minor axis, if this is B and this is B, then this will be 2B units long. And the center, you probably could have guessed this one, the center right here is going to be at HK. The HK has typically been, like even for a circle, the HK would be the center of the circle. Here is the center of the ellipse. Okay, so keep those things in mind. All right, now how about the foci? Notice here I have not yet talked about the foci. The foci are just kind of somewhere in no man's land, like here and here. How do you know how far they are away? Well, if you look at the graph, you see how it kind of depends on the A and the B. Depending on how far it's elongated in one direction or another, that's going to influence where your foci are. Well, the foci are C units away from the center, not quite as far as the vertex. But what is C? Well, C is dictated by the relationship C squared equals A squared minus B squared. So you'll need to commit this to memory as well as these formulas here to help you graph certain ellipses and whatnot. So anyway, so hopefully that helps you understand ellipses just a little bit better. If a lot of that seemed too much like theory, that's totally okay. In the upcoming videos, we're going to work quite a number of examples dealing with ellipses.